Welcome to this session on evaluating double and triple integrals. I'm Suman Matthews. We will learn the basic techniques of evaluating double and triple integrals. So we directly start with problems. Evaluate integral 0 to 1, integral 0 to root 1 minus y squared, x cubed y dx dy. So this is the question. As the order suggests, you have dx and dy. So this is integral. The inner integral is with respect to x. So it is basically integral x equal to 0 to root 1 minus y squared, y equal to 0 to 1, x cubed y dx dy. So we are integrating this with respect to x. So it becomes integral y equal to 0 to 1 remains as it is. Integral of x cubed is x raised to 4 by 4y within the limits x equal to 0 to root 1 minus y squared dy. So this is the last step in the previous slide. So when you are substituting, you get root 1 minus y squared raised to 4. That is 1 minus y squared squared by 4 dy. So that is take out the 1 by 4. 1 by 4 integral 0 to 1. Y into, when you expand this, you get 1 minus 2y squared plus y raised to 4 dy. Open the bracket, so you get 1 by 4 integral 0 to 1. Y minus 2y cubed plus y raised to 5 dy. This was the last step in the previous slide. So integrating it, you get 1 by 4 y squared by 2 minus 2 y raised to 4 by 4 plus y raised to 6 by 6 within the limit 0 to 1. So you get 1 by 4 into half minus 1 by 2 plus 1 by 6, which is 1 by 24. A little basic knowledge of integration is needed for this topic. Coming to question 2, evaluate integral minus c to c, integral minus b to b, integral minus a to a, x squared plus y squared plus z squared, dz, dy, dx. So this is a question. So this is basically outer limit is x. So x equal to minus c to c, y equal to minus b to b, integral x equal to minus a to a, x squared plus y squared plus z squared, dz, dy, dx. The first integral we are integrating with respect to x. Now we have a property that integral minus a to a fx dx is twice integral 0 to a fx dx if f is even. F is even because it is x squared, y squared, z squared, they are all even functions. So this becomes 2 into 2 into 2, that is 8 integral x equal to 0 to c, integral y equal to 0 to b, integral x equal to 0 to a, x squared plus y squared plus z squared, dz, dy, dx. So this is the last step which we had in the previous slide. Integrating this becomes x squared. We're integrating this with respect to z. So you get 8 times integral x equal to 0 to c, y equal to 0 to b, x squared z plus y squared z plus z cubed by 3. Within the limit z equal to 0 to a, that is 8 times integral x equal to 0 to c, y equal to 0 to b, substitute for z, so I get x squared a plus y squared a plus a cubed by 3 dy dx. This is what we had stopped at. Now we are integrating with respect to y. So it is 8 times integral x equal to 0 to c, x squared ay plus y cubed by 3a plus a cubed by 3y within the limits y equal to 0 to b. So substituting for y, we get x squared ab plus a b cubed by 3 plus a cubed by 3b. And now we are integrating with respect to x. We had stopped at this. So we get 8x cubed by 3ab when you are integrating this with respect to x within the limit 0 to c plus xab cubed by 3 plus a cubed b by 3x within the limits x equal to 0 to c. So substituting the limits, you get 8abc cubed by 3 plus ab cubed c plus a cubed bc by 3. You can take out abc by 3 out, so you get 8 by 3 abc, a squared plus b squared plus c squared, which is your answer. Next question, evaluate integral 0 to a, integral 0 to x, integral 0 to x plus y, e raised to x plus y plus z, dz, dy, dx. So this is actually integral z equal to 0 to x plus y equal to 0 to x equal to 0 to a, e raised to x plus y plus z, dz, dy, dx. We first integrate with respect to z. So it is integral x equal to 0 to a, y equal to 0 to x. You can take out e raised to x plus y out. So it becomes e raised to z. Integral of e raised to z is e raised to z within the limit z equal to 0 to x plus y dy dx. So when I substitute, I get integral x equal to 0 to a, integral y equal to 0 to x, e raised to 2x plus 2y. This is actually e raised to x plus y. You get e raised to x plus y minus e raised to 0, which is 1, dy dx. So that is integral x, integral y. This is a raised to m into a raised to n is a raised to mn. So this is e raised to x plus y into 2 minus e raised to x plus y, opening this bracket, dy dx. So that is e raised to integral x, integral y, e raised to 2x plus 2y, opening the bracket, minus e raised to x plus y dx dy. You are integrating with respect to y now. So you get integral x equal to 0 to a, integral y equal to 0 to x. Just split it up into e raised to 2x into e raised to 2y minus e raised to x into e raised to y dy dx, and then integrate with respect to y. So it becomes integral over x. Integral with respect to y is e raised to 2x e raised to 2y by 2 minus e raised to x e raised to y within the limits y equal to 0 to x. Substitute, so you get e raised to 2x into e raised to 2x by 2 minus e raised to x into e raised to x. Now this is where students go wrong. They will write this as 0. But this is not 0 because e raised to 0 is 1. So it is e raised to 2x by 2 minus e raised to x. So when you open up the bracket, you get integral over x. This is e raised to 4x by 2 minus e raised to 2x minus e raised to 2x by 2 plus e raised to x dx. We had stopped at this. So simplifying this, you get integral over x e raised to 4x by 2. You can take these two together. So I get minus 3 by 2 e raised to 2x plus e raised to x dx. Now you can integrate with respect to x. So you get 1 by 8 e raised to 4x by 4, which is 8. 3 by 2 e raised to 2x by 2, which is 4, plus e raised to x within the limit 0 to a. We had stopped at this. So this is e raised to 4a by 8 minus 3 by 4 e raised to 2a plus e raised to a minus e raised to 0 is 1. So 1 by 8 minus 3 by 4 plus 1. So that will give you e raised to 4a by 8 minus 3 by 4 e raised to 2a plus e raised to a, and this will give you minus 3 by 8. So this is your answer. Question 4. Now these are polar coordinates r, z, theta. Evaluate integral 0 to pi by 2, integral 0 to a sine theta, integral 0 to a squared minus r squared by a, r dz dr d theta. So we are integrating, this is integral with respect to z equal to 0 to a squared minus r squared by a, r equal to 0 to a sine theta, theta equal to 0 to pi by 2. So first integrating with respect to z, you get r integral of dz is z within the limit z equal to 0 to a squared minus r squared by a. So we substitute here, so you get r and you get, we had stopped at this step, so you get r into substituting a squared minus r squared by a minus 0. So you can take out 1 by a, so it is 1 by a integral over theta integral over r. Opening this bracket, you get a squared r minus r cubed dr d theta. So this is our last step which we stopped at. Now integrate with respect to r. So you get 1 by a integral theta equal to 0 to pi by 2 a squared r squared by 2 minus r raised to 4 by 4 within the limits r equal to 0 to a sine theta d theta. So now substituting the limits, you get 1 by a integral over theta a squared by 2 a squared sine squared theta minus 1 by 4 a raised to 4 sine raised to 4 theta minus 0. So this was our last step where we stopped at. So it is 1 by a integral over theta a raised to 4 by 2 sine squared theta minus 1 by 4 a raised to 4 sine raised to 4 theta d theta. Now integral theta equal to 0 to pi by 2 sine raised to n theta is n minus 1 by n into n minus 3 by n minus 2 up to half to up to pi by 2. This is a reduction formula. This applies where n is even. N is even in both cases. So applying the reduction formula, this is 1 by a raised to 4 by 2 Applying this, you get half. N minus 1 will give you 1 by 2 into pi by 2 minus 1 by 4 a raised to 4 sine raised to 4. So you get n minus 1 by n, which is 3 by 4 into half up to pi by 2. So when you simplify this, you get a cubed, which is outside. A raised to 4 will cancel with the a and you get a cubed. Pi by 8 minus 3 pi by 6 to 4, which is 5 pi a cubed by 32, which is your final answer. So you've learned some basic techniques on evaluating triple integrals. Now I know this seems dry and difficult, but you have to master it, and to do that you have to take a pen and paper and practice along with me. Remember, nothing is difficult if you practice, especially a subject like maths. Thank you and see you in my next session.